Find the area of the 4-leaf rows r equal to cosine 2 theta. I'm going to first draw this in rectangular coordinates and then get a graph sketched so it will help me to find this area. So I have a cosine 2 theta with amplitude 2. And so I go 1, 2, 3, and the fourth one is going to be pi because the period is 2 pi over 2. So this middle one is going to be pi over 2, and this one's going to be pi over 4. Now as I draw the graph, we know at 0 the cosine is 1 multiplied by 2, so we'll put it up here at 2. And then we are going to cross in the first fourth, then down to the minimum, and then cross, and then back to the maximum. So our graph looks like this. Now let's go ahead and draw this in our polar coordinates. And so we'll go out as far as 2 each way. And at 0 we are out at 2. And then when we get to pi fourths we go to 0. So here's our pi fourths, and we're going to go around to 0. And then between pi fourths and pi halves it looks like we are negative, and when we get to pi halves we're at negative 2. So at pi halves we're down here at negative 2. So we came down like this. And then from pi halves to 3 pi fourths we're going to go back to 0. So as we're over here we're doing those negatives back and we get back to 0. And then from 3 pi fourths to pi we go out to 2. So you can see we go like this. So we got part way around here as we went to pi, and you could see that then if I continued this graph I would continue getting these other pieces when I went around, and when I got to 2 pi I would have my rows. Alright, so what I want to do is find the area inside of this. So this here. And they don't look like it in my graph, but these leaves are actually symmetric. So we could find the area inside of one leaf and then multiply it by 4. So I think that's what I'm going to do here. So let's see. Or, you know, another thing we could do, when we did this first piece right to here, and when we went from 0 to pi over 4, we did this piece right here. So if I actually found the area of that piece, that would make a pretty easy integral, because I could have my limits be 0 on one end and then pi over 4 on the other. Then I could multiply it by 8. So you'll want to use symmetry to make your integrals fairly easy when you're doing these. So that's what I'm going to do. I'm going to integrate from 0 to pi over 4, but then I'm going to multiply it by 8 because 2 of those will give me 1 leaf, and then I've got 4 leaves there. Here is a reminder of our area when we're in polar coordinates here. So we're going to have 1/2, which we're going to put out in front, and then we have our function of theta squared. So here is our function of theta. So if we square that we'll have 4 cosine squared 2 theta d theta. Okay, then we remember what we learned about integrating trig functions. Let's see, here we have 4 and we have 4, so we have 16. Integral 0 to pi over 4, but we know that if we have this cosine squared, that is 1/2 times 1 plus cosine. We need double that angle, so 4 theta d theta. Oh, we got to go back and remember when we were doing those trig function integration. Now we can go ahead actually and move this out here as well. So we'll have an 8 out in front. And then integrate here is going to be theta. Integral here is going to be plus 1/4 sine 4 theta. We need that reciprocal because of the chain rule. And then we need to evaluate that from 0 to pi over 4. So let's see what we've got here. So we have 8 multiplied by pi over 4 plus 1/4, and here we'd have the sign of pi, which of course is 0, so that's going to be gone. And then lower limit minus 0 plus 1/4 sine of 0, that's also 0, so that's going to be gone as well. So all as we have left is our 8 pi over 4, which is 2 pi.